So, welcome back to term 3, our last term. We've got one test to go. We've got a folio to finish off. So our last test will be on chapter 8 and chapter 9. So we'll basically work through this unit over about 6 weeks. And you'll find a lot of the exercises are quite short. Today, g'day Hugo. Good mate, welcome. Today we will go over 3 exercises. Really 8A is very short. 8B.1 just introduces you to the idea of probability density functions, and 8B2 refines it a bit further. So it's not going to be overly challenging today. Most of our lessons this term will be short exercises that we might spend 40 minutes doing. You'll probably finish the work in class, and then you'll be able to dedicate some time to your folio. So this term, particularly in the early part of the term, we'll have a lot of time to work on our folio in class. That being said, you still are expected to work on it at home. The other thing about your folio task is you'll notice there's a place to upload it on Sector, which we'll get you to do a bit later today. So that's just a sort of a checkpoint, okay? So it's just a checkpoint. If something goes missing, all right, you've at least got a copy there that's you've done a bit of, and that's going to be a way for me to say, yes, satisfactory, I'm happy with the work you've done in the holidays. So that's where we're going to upload that to.
Is that an A?
Yes. Let's begin. So we'll have a quick read through 8A here. Now wait a second, use that marker in my pocket. So 8A, now the first thing we're going to talk about is the difference between continuous random variables and discrete. We should remember we talked about this in exercise 7A, and discrete variables are ones that you count, so that might be goals in a game of soccer, pencils in your pencil case, whereas continuous variables are things that you measure. And they're continuous because they occur on an interval. All right, so examples might be you're measuring someone's height, the time it takes them to drive to school. All of those things are occurring on an interval. They do not take discrete values. So here we are in our example, we have a continuous random variable x can take any real value within a particular range. Here we have 50 eggs are weighed and their weights are shown in the frequency table below. So what this says is between 50 and 55. So what that means, just that notation, we're familiar with it, but just to really emphasize, we have 50 is less than or equal to x. So that means the weights of eggs that are exactly 50 grams are included in this interval, and it goes all the way up to 54.9 recurring, right? It doesn't include eggs that weigh 55, they're going to occur in the next interval. Now we have 6 eggs that weigh between 50 and 55, and just following on you can see the frequency there for a total of 50 eggs. And then we have the relative frequency, which is an indication of the probability. It's not the probability, but it's an indication because it's a sample. It's an indication of the probability that an egg will weigh between 50 and 55 grams, 0.12. All right. So let's jump down, then we have a frequency table. That's another way that we can express it. Okay, so here we have the probability of a continuous random variable being equal to an exact value is always 0. So let's just talk about what that means, okay? So, and in the example there I've listed, the probability that an egg weighs exactly 62.9 grams will be 0. And that's because if you have a fine enough scale that goes to, let's say, 10 decimal places or 20 decimal places, you will always find some variance. No egg weighs exactly 62 grams. It's always going to be a nanogram, all right? Difference between them. So the probability density calculations always occur over an interval. Remember in discrete, when we're doing binomial, we're saying, what's the probability of getting exactly 6 heads? Okay, so it's an exact outcome. Here, it's always going to occur between 2 intervals. Like in our example A here, find the probability that the weight of a randomly selected egg is between 55 and 65 grams. So we're looking at the table, all right, and we have, well, the probability of it being between 55 and 60 is 0.26. And the probability of it being between 60 and 65 is 0.4, and so therefore the probability that it's between 55 and 65 will be 0.66. We're adding those two together. All right. So that's how we're answering exercise 8A, Introduction to Continuous Random Variables. Sorry, I've answered that in the 8B.1 part. But is everyone okay with that? Our answer to part A is 0.66. Okay. So now what we're looking at then in 8B.1 is what's called a probability density function. Now we actually did this with discrete variables as well. You might look at this and the only difference is it would say something like valid for x equals 0, 1, 2, and 3. All right, so we would have it's valid for exact values of x. Here we have it's valid over an interval of x. And remember when we were doing discrete, what we had to do is we had to plug x is 0 in, plug x is 1 in, plug x is 2 in, and x is 3 in, and all of those probabilities had to add to 1, right? Similarly, with the probability density function, what it means is the area under this curve over this interval has to add to 1. Okay, so probability density function. We've got a couple of examples here. So for a continuous random variable over domain between A and B, this is a probability density function. And basically it's area over an interval. So we've got two properties. Firstly, the function has to be positive. Why is that? Probabilities can't be negative. And the second property is that all probabilities add to 1. So we'll flip the page over. We have listed here a number of properties. So we have mean, median, mode, variance, standard deviation. So that we're going to be performing those calculations just on our calculator today. So here we have the function x on top of a. Now whenever we see something like this, right, a is a number, x is our variable. We should always think about it as it's 1 on a times by x, right? It's the equation of a line, mx, all right? It has a slope of 1 on a, and we're told it's valid between 0 and 4. Now because it's valid, it means that area under this function from 0 to 4 equals 1. So the first thing we're going to do is determine the value of a. So we have the integral from 0 to 4 of the function 1 on a times x is equal to 1. All right, now this one we will process manually just to get our mind ticking over the integration and so forth. Now remember 1 on a is a constant, let's rip that out the front. So what we have here is we have 1 on a times the integral from 0 to 4 of x with regards to x equals 1. And we can even do something really clever here by multiplying both sides by a. Right? If we multiply both sides by a, we're going to have the integral from 0 to 4 of x is equal to a. Right? And so we're trying to determine the value of a. Let's go through and do that now. So when we integrate x, we'll get x squared on top of 2. We don't need plus c because it's a definite integral. We'll sub in our lower and our upper boundary. We'll have 4 squared on 2, take 0 squared on 2, which is 16 on 2, which is 8. Okay, so our value of a, that gives us a valid probability density function, is 8. So the answer to part A equals 8. Okay. Part B says find the mean, find the median, and find the mode. So first we'll do the mean. All right. So the mean, the formula for the mean is the integral from a to b of x f of x. Okay, so that's the formula. So in our circumstance, it's going to be the integral from 0 to 4 of x times x on 8. And we're just going to type that into our calculator. Most of these we will type straight into our calculator. So integral x squared on 8, 0 to 4. And I've got 8 on top of 3. Okay, so that's the mean. Okay, next let's do the mode. All right, and so we'll have a read of the mode. The mode is the value of x which maximizes f of x. That means it's the value of x that corresponds with the highest y value. So often what that means is you'll need to look at the graph, okay? Now we know that this function is the equation of a line. It is 1 on 8x, right? And we're going from 0 to 4. All right, that's the region over which it's valid. It's a probability density function, so the area under the curve all adds up to 1, okay? What is the x value that corresponds with the highest y value? 4, right? Okay, so we can see that just from reasoning about what we know about the equation of a line and so forth. The highest y value occurs when x is 4, which means the mode is 4. Okay, so the mode is just always the highest y value. What we can do is we can graph it, we can restrict the domain, and g-solve the maximum y value. Okay, now the median is a little bit more tricky. I'll explain the median visually. The median is the point on the graph such that half of the area occurs below it and half of the area occurs above it. Okay, it splits the graph in half. Half the data lies below, half lies above. So what this means, now with this one we will do manually, although we can use the equation solver on our calculator as well, is we're going to solve from 0 to m of our function equals 0.5. All right, so we know from 0 to 4, the probability is 1. And so we want to know what's the value of m such that it's halfway. That gives us a probability of 0.5. Okay, so we'll process this. We're going to have x squared on 16 from 0 to m equals 0.5. Sub in our upper and lower boundary. This gives us m squared on 16 equals 0.5. Times both sides by 16. We'll have m squared is 8, which means n is plus or minus the square root of 8. But we reject the negative solution because a negative value of 8, root 8 would be over here somewhere, right? So our median is positive square root of 8. I'll write that here. Okay, now the way we could do that on our calculator to determine the median, we know how to use solve n, and we can type in this integral expression. All right, solve n, we just type that in exactly, solving for x, solving between 0 and 4. Okay, so we can restrict the domain. Do we want to recap that syntax? Yep. So what we'll do is we'll go option, calc, solve n. All right, and we're just going to type this expression in, except we're going to have an x there instead of an m, right? So we have the integral from 0 to x of the function x on 8, and then equals 0.5, put a comma. All right, so let me write out the syntax for you. So we solve n, we have our equation. Okay, we're solving for x, so we always must put the variable there, and then we're interested in the domain between 0 and 4. Okay, between 0 and 4, because that's the domain over which the probability distribution density is valid. Syntax error. X, I think X. More solutions exist, yep. And 2 root 2. Now, 2 root 2 is the same as root 8. I'll just show you why quickly. So root 8 could be expressed as 2 times 4, which is the square root of 2 times the square root of 4, which is root 2 times 2, which is 2 lots of root 2. Okay, so both of those mean exactly the same thing. We'll accept 4 marks for either. Okay, you type in your calculator should simplify it. Okay, so that's part B done. Then we're on to part C, where we're going to find the variance and the standard deviation. And we should remember the variance is just the standard deviation squared, right? which means the standard deviation is the square root of the variance. So all we'll do is we'll find the variance first and then we'll square root it. And you can see we've got two formulas there. So we'll just use the first one. We have the variance is the integral from a to b of x squared f of x, take the mean squared. Just get rid of that out of the way. So in our circumstance, we're going to have from 0 to 4 of x squared times x on 8. And then our mean is 8 on 3. Now notice this 8 on 3 is outside the integral. Here's dx, so we're integrating this part, and then we're just subtracting 8 on 3 squared. So let's evaluate that. We have x squared times x on 8. And simplifies to 8 on 9. And then the standard deviation is the square root of the variance. Okay, now this is revealing some interesting properties about the mean, the median, and the mode, and skew, like the skew of a graph. Maybe you remember that word, we have positive skew and negative skew. I'm not going to address that right now, I think we'll talk about that a little bit later. But notice how the mode is here, the mean is here, 2 root 2, and what was our, sorry, that's the median. The median is 2 root 2, that's the mode. And our mean was 8 on 3, which is 2.6. So that's going to be what here. So notice how there's a difference amongst those values as measures of average. For now, just notice that they're different. Now we have one more part to do, which was find the probability of the event between 1 and 2. So this is a probability density function. And what we're going to do here is we're going to say, well, what's the probability that an event occurs between 1 and 2? That our distribution takes on this region, that we're selecting a value from the distribution and it occurs in between 1 and 2. All we're going to do for the last part here is the integral from 1 to 2 of our probability density function. Because what does the probability density function tell you? It tells you the probability of an event occurring between two given values. All right. Obviously, between 0 and 4, that's the whole field over which values can occur. So that adds to 1. Between 1 and 2, we'll just go straight to our calculator. 3 on 16. Excellent. Now, of course, we expect this value to be between 0 and 1, right? Because it's a probability. Probabilities always occur between 0 and 1. Very good. Now, you can see why we do 8b1 and 8b2 together. Okay, because 8b1 just sort of introduces you to this, finding the A value, and then 8b2 introduces you to the mean, median, and mode. So I think it makes sense to do them certainly together. But yeah, that's enough for us to rip in today to 8a and 8b1 and 8b2. So we've got our checklist on the front of our notes books. So what does it say for 8a for those that don't have it? What question 1, 2, 3, 4 for 8a?